Okay, so this is PreE-4.3, which is simplifying basic logs. So I'm first looking over the properties of logs we went over at the end of E4.2, which is just our basic properties that we need to be aware of. These are all things that we can simplify or solve for in order to figure out how to simplify them. But if we can remember them, that's even better. Okay, so remember there is another way to remember the shortcut of logs. We can do this little base raised to the equal side gives us the inside number. Okay, so this is true because a to the 0 power equals 1. Okay, the way to prove this, again, is if I had something like log base, I don't know, 2 of 1. If I wanted to see what that would equal, I'd set it equal to y. To get rid of log base 2, I would take exponential base 2 and move my log equation up into the exponent. My log base 2 and my exponential base 2 would cancel, so I'm left with 1 is equal to 2 to the y power. So here I'm trying to figure out what power of 2 would equal 1. Okay, and the only power of 2 that would equal 1 is 2 to the 0. Okay, so then by our base exponent property here, we could drop our 2's, which means that y has to equal 0. So this is the way I went over solving it in 4.2. You can work it out that way, or you can just remember the little shortcut that I did over here, that the little base raised to the equal side gives you the inside number. Okay, so that's kind of how all these examples are. These are, again, the ones we've already been over. This is log base a of a to the first power. Remember, anytime we have log base a of a, so anytime the log base matches the exponential base, those just cancel. And that's why that equals 1. I'm left with whatever the exponent is there. Okay, same thing here. I have log base a and exponential base a. So those would cancel, and notice I'm left with the x. Now, notice the x does not stay in the exponent. It comes down and it is just a normal number now. Okay, so make sure when you're simplifying these, you don't leave that exponent up in the exponent. It comes down as a regular constant term now. Okay, because we're simplifying that, and what it simplifies to is whatever's in the exponent. Okay, the same thing is true. These are pretty much the same rules. Anytime you have an exponential base and a log base that match and they're evaluating one another, they cancel. So this would be something like log base 4 evaluated at 4. Those would cancel. Excuse me, 4 to the x. This would cancel and leave me with just x. Or if I had 4 raised to the log base 4 of x, those would cancel and I'd be left with x. Okay, so that's what this is saying. If I have an exponential base and a log base that match, they cancel, and I'm left with whatever's in the exponent as a constant regular term. Okay, you didn't have to mark all this up. I was just explaining as I went. This other little piece right here is all the same rules, but written with the natural log. Remember that ln of x is the same thing as log base e of x. Okay, so if you see an ln, it's still a log, but it's an implied e for the base. So here, same thing, ln of 1 equals 0 because e to the 0 power equals 1. Here, ln and e cancel. I have one copy of my e there. So when I cancel my ln and my e, I'm left with my exponent, which in this case is just 1. On the next one, I have ln of e to the x. Ln and e would cancel. I'm left with just x. And then here, my exponential base is e. My exponent log base is e. So those would cancel, and I'd just be left with x. Okay, so we're going to use these properties to simplify these next few examples. And we're really basically looking at these two and simplifying these, in that we want the exponential base and the log base to match so that we can cancel them. Okay, so I'm going to go ahead and look at a few examples. On this first one, what I look at is the log base. Okay, this is log base 3. So I want to know, can I write 27 as 3 to some power? If you don't know it off the top of your head, you can always prime factor 27. 27 is 3 times 9. 9 is 3 times 3. So notice I have 3 copies of a 3, which means that 27 is the same as 3 cubed. Okay, so I can rewrite this log as log base 3 of 3 cubed. And then using the powers we just went over, since I have log base 3 and I'm evaluating exponential base 3, those cancel. And this just equals 3. Okay, notice the 3 is no longer in the exponent. Since everything canceled out, that exponent is now my answer, which is just a regular number. Okay, same thing on the next one. I want to know, can I write 49 as 7 to some power? If you're not sure, you can factor it. 49 is 7 times 7, which means that this is 7 squared. So I can write this as negative log base 7 of 7 squared. Okay, here notice my log base 7 and my exponential base 7 cancel. Now here I'm left with two things. I'm left with this negative out front. Okay, the negative out front is like a -1. And then I'm left with the 2 from the exponent. So whatever I have, oops, not -2, +2. Whatever I have left over, I multiply. So the -1 from the front times the 2 from the exponent gives me -2. Okay. Let's look at another one. This one's a little bit different. Here I'm looking to get it, the inside number written with a exponential base 6. So first thing I want to do is I know that 36 is the same thing as 6 squared. So I'm just going to rewrite this. So this gives me log base 6 of 1 over 6 squared. Okay, so I just want to write it with an exponential base 6. And then I can't cancel yet because I don't have just a 6 in there like I did on this last one, just having a 7. I have 1 over 6. So I need to move that 6 to the top. Remember, whenever we move our exponential bases across the fraction line, it changes the sign of their exponent. So now what I have is log base 6. When I move that one up, it becomes 6 to the -2 power. Okay. And now that I have log base 6 of 6, those cancel, and I'm left with my exponent, which is just -2. Okay. Let's look at another one. This one might be just a little bit easier. Okay, I have ln of e. Remember, ln of e is the same thing, or sorry, ln of e. ln of e is the same thing as log base e of e. Okay, because ln is the same thing as log base e. So anytime you see an ln and an e side by side, those cancel because they already have the same bases. Okay, now here I have ln e to the 2x. So when I cancel my ln and my e, I'm left with my exponent, which here is 2x. Okay, not too bad, maybe. Let me look at a couple more. These next ones, I have a couple more steps, but it's still just simplifying. So here I have a common log. Common log means I don't have a base written here. If there's no base written here, it's an implied 10. So what I'm going to do is I'm just going to simplify each term individually. Okay, so I want to write each inside number hopefully as 10 to some power. Okay, when you write this as 10 to some power, you count the zeros. So I have 1, 2, 3 zeros. So that means 1,000 is the same as 10 to the third power. Okay, 100, if I want to write it as 10 to some power, again, I count the zeros. I have 2 zeros. So this is the same as 10 squared. So I'm just going to rewrite this. And you don't have to write log base 10, but if you're a little fishy on it, I would write it just so you know why things are canceling out. So this first term becomes log base 10 of 10 cubed minus my second term, log base 10 of 10 squared. Okay. Log base 10 of 10 cancels, so the first term just becomes 3. Log base 10 of 10 cancels on the second term, and I'm left with -2. So then I just do 3 minus 2, which is 1. Okay, let's look at another one. Here's another one with ln. Remember, ln is a log, the natural log base e. Okay, so when I see that I have an ln and the inside base is e, I know ln and e are inverse functions, so those cancel. When I cancel those, notice what I'm left with is I'm left with the 4 out front times what was in the exponent, which is 1/2 x squared. Okay, so then I just simplify. 4 times 1/2 is 2. If you're not sure, you can multiply it out and get 4/2 x squared and then reduce, which gives us 2x squared. Okay. All right, let's look at another one with e's here. Again, here's 2 terms. I simplify each term individually, and then see if I can simplify more. So the first one, I have ln of e to the 6th. Remember, ln and e are inverse functions, so those will cancel. On my second term, that just leaves me with -6. On my second term, I'm hoping to be able to write 32 as some power of 2. If you're not sure, just simplify it out. So here, 32 is the same as 2 times 16. 16 is 2 times 8. 8 is 2 times 4. And 4 is 2 times 2. So if I count up all my 2's, notice I have 5 copies. So that means 32 is the same as 2 to the 5th power. So I'm going to go ahead and simplify this one by writing this as log base 2 of 2 to the 5th power. Okay. So now that I have log base 2 and exponential base 2, those will cancel, and I'm left with -6 minus the 5 from my exponent, which gives me -11. Okay. So on all of these, notice we just had one expression or 2 terms, and we're just simplifying. What we're going to do on the next one is use the same idea of getting rid of logs by getting the log base and the exponential base to cancel in order to solve an equation. So we're going to have to cancel out the log and then potentially do some extra solving. Okay. So on each of these, we're just going to solve the equation. The first one, I don't have a base written there, so this is an implied log base 10. Okay, I want to write this as 10 to some power, so I count my zeros. I have 1, 2, 3, 4. So this is going to be 10 to the 4th power is equal to 4x. Okay, now I have log base 10 of 10, so those cancel, they're inverse functions, and I'm left with just the 4 from the exponent is equal to 4x. And now I have a really simple equation to solve. I just divide off my 4. When I divide off my 4, that tells me x equals 1. Okay, not bad. I will tell you, on some of these, I think whenever, I don't know if I have one like it, no I don't. On some of these, whenever you cancel out the log, you'll be left with something like, I don't know, 2x equals x squared minus 1, something like that. If you're left with something like that, if you have an x squared, that means you're going to have to factor. So here I would just move everything to one side. So I would do like 0 equals x squared minus 2x minus 1, and then either factor or use quadratic formula to get your answers. Okay, both of my examples, I think I only have the first power of x, so they're a little bit easier to solve, but I think there might be one you have to factor on your worksheet. All right, let's look at one more example. Same thing here. I want to write 64 as some power of 2. So I'm going to go ahead and just off to the side, I'm going to factor 64. 64 is the same as 8 times 8. Okay, 8 is 2 times 4, and 4 is 2 times 2. Same thing on this other 8. 8 is 2 times 4. 4 is 2 times 2. I count up all my 2's and notice there's 6. So I can write this one as negative log base 2 of 2 to the 6th power equals 8x. And then notice my log base 2 and 2 are inverses, so those cancel. So I'm left with the -1 out front times the 6 from my exponent is equal to 8x. Okay. So I end up with -6 is equal to 8x, and then I just divide off my 8. When I divide off my 8, I get x is equal to, after I reduce, -3/4. Okay. So that's all of PreE-4.3, which is simplifying basic logs. You do have a worksheet for this assignment, which is on pages 3 and 4 if you're working out these notes. If you don't have these notes, you can print it off of the Math 118 worksheets tab in your My Math Lab. Okay, so do this on hand, scan and email it to me. Let me know if you have any questions.